What up, everybody? Welcome to Monday, this day off. Absolutely wonderful President's Day. And what to do than more math. So here we go. Let's finish up this log homework. We're going to be doing 13 all the way to the end of the assignment. Here we go. So step one here, I'm seeing two logarithms that have identical bases, and they have a subtraction sign in between. So I'm going to take what is on the inside here, and what's on the inside there, and divide them. So we're going to end up writing as log base 9, 7 divided by x plus 8. Not too big a deal. Nothing changing that right-hand side. After that, we need to use our logarithm loop. Logarithm loop states that we're going to be taking 9 and we're going to raise it up to the first power, and it's going to equal the inside. So in other words, 9 raised to the first power is equivalent to the inside. And now we're back to algebra 1. So 9 to the 1 is just 9. Easiest way to solve an equation like this, and this might be a good little trick for you to have written down. It's pretty useful in physics classes and other places where you have equations that look like this quite often. If I have something of the form a equals b over c, I can immediately rewrite this as c equals b over a. This will work for every single time that basically just switch the positions of these two things, and I will end up solving the answer well. That's an optional thing to do on this problem. Some people don't want to do that because it's going to give you some fractions. Either way, you're going to have to deal with fractions on this problem. I don't know. It's just an option if you want to. So just two different methods. Method 1, multiplying up, I'm going to have 9x plus 8 equals 7. That's method 1. And the other method is just going to be making this instead x plus 8 equals 7 over 9. Either way, you have to do one of these two things to get x alone. If you do it here, you get x equals 7 over 9 minus 8. And then use a calculator for yourself, and you'll get negative 65. I said 65 and wrote 67. That's a problem. Wow. That is atrocious. I'm going to rewrite this. X equals negative 65 over 9. Alternatively, the other way to do this one is to go ahead and multiply out, and we have 9x plus 8 equals, oh, not equals 72. I can distribute correctly. 9x plus 72. Subtract 72 on both sides. 9x equals negative 65, and we get to the same answer either way. I don't care which way you do it. All algebra 1 to me. Pick your favorite option. On to the next one. Number 14. Number 14, this is very similar to the last question, but instead we have a plus sign in between. Plus sign means multiply instead. So that's what we're going to do. So x minus 12 is going to get multiplied by x minus 6. Let's go ahead and distribute that guy. Doing some foiling, you know what I'm talking about. Boom, 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 boom. This whole thing, if you do that correctly, you get x squared minus 18x plus 72. Same exact log loop as that last question. We're going to have to do 4 raised to that power is the inside. So that's going to be 4 squared is equivalent to x squared minus 18x plus 72. 4 squared is 16. Subtracting 16 on both sides is going to give me 0 equals x squared minus 18x. Subtract 16 there. Subtracting 10 is 62, and 6 more is 56. Then we just got to factor. Factoring this, it turns out that x minus 14 and x minus 4 are going to work for my factors. And therefore, x equals 14 and 4. However, if I plug 14 back in, I'm fine. 14 minus 12. This is fine. It gives me an answer that's good to go. However, if I plug in 4 into this, 4 minus 12 is negative 8, and I can't have negatives in here. So we're going to go ahead and cross out 4 as an answer. It is not a correct answer. Only 14 is. You know what? I don't like this pen, so I'm going to switch pens. I'm going to switch over to this color, dark blue. Let's do the next one. Number 15 is a lot easier. The only trick is you have to remember what the base is on this problem. So Starts off the same. Log of 6x. We're just multiplying those two guys. We just got to remember there's an invisible 10 there. That's the key. There's an invisible 10 just chilling down there whenever nothing's written. 10 to the 1 equals 6x. And therefore 10 over 6 equals x. Probably should reduce that to 5 over 3. Oops. You guys can't see what I'm writing. Divide top and bottom by 2 or use your calculator to reduce that. Either way is cool with me. Let's go on to number 16. So over here, number 16, log base 6 of 2 minus log base 6 of x equals 3. Subtraction means division, so we're going to go ahead and do that dividing. Same exact thing, that log loop, 6 raised to the third power equals 2 over x. And then using my little trick of what I was saying back up here, if I can just switch the positions of two things like this, A and C, C and A, switch. We can rewrite this as x equals 2 over 6 cubed. That's one of the numbers we wrote down. That's 216. And that reduces to 1 over 108. Not too terrible. Let's continue on to number 17. Number 17, again we see the plus sign in the middle, which is meaning multiply. So we're going to have log base 7 of x plus 16, and that's going to be multiplied by x is log base 7 of 57. And now here's the deal. Log base 7 is on both sides. If it's log base 7 and the whole thing is within log base 7, I can kind of just pretend the logs aren't there, just cancel them out basically. And we're going to get x squared plus 16x equals 57. Now it's kind of a freebie question again. X squared plus 16x minus 57 equals 0. And what two numbers multiply to negative 57 and add to positive 16? Oh boy, what is that going to be? 19 and 3, I guess? Yeah, x plus 19 and x minus 3 equals 0. So x is negative 19 and positive 3. But negative 19, if I plug it in, it actually fails on both up there. So negative 19 is not an answer, and we have just 3 as an answer. Let's go on to number 18. Uh-oh, my paper is not cooperating with me. All right, so this one, same exact thing as that last question, except we got a minus sign in the middle. So let's just do a little bit of trick step work. We got x minus 2 over x minus 1 equals 45. We kind of just skip writing the logs because we know they're going to cancel out as long as we do the division first. Similar to that problem up there, we're going to go ahead and multiply that x minus 1 up here. We're going to get x minus 2 equals, we got 45, x minus 45. So again, I'm kind of skipping steps here. I just multiplied up here at a distributive property to get both of those. And finally, we're going to go ahead and subtract the 45x. We get negative 44x equals, and adding 2 over there is going to give us negative 43. And finally, x is 43 over 44. Oh, wait. Did I make a mistake? Hold on, I gotta think for a second if I made a mistake here, because I subtracted 44, added. The reason why I'm saying if I made a mistake is, look, if I plug 43 over 44, that number is less than 1. If I plug it in up here, that's going to cancel out, and this is going to be a no solution problem. So this means no real solutions, actually, on this problem. It doesn't work out. I gotta double check, make sure I didn't make a mistake. I'm going to try one more time. Yeah, I'm not seeing anything, actually. This is a no real solution problem. That happens sometimes. There you go. All right. So this next one is, it says, give an exact answer. Practice getting the decimal answer at least twice. So that's optional, really, getting that decimal answer. I would recommend doing it on the calculator. On the test, I will ask for it exactly one time. I just want to make sure you're able to use the calculator, but I don't really care. I care more about being able to do the math portion of it. The calculator is kind of secondary. It's just more of the, are you able to use the calculator if you had to kind of thing. So I will show you how to do that on the calculator here in just a moment on the video, but ultimately it's more worried about doing it actually by hand. So number 19 here, we have 13 to the x equals 91. So we're going to go ahead and use our log loop idea. So we're going to rewrite this as log base 13 of the inside is the exponent. And that's it. That's actually the whole question. There's nothing else to that problem. And if you did want to type this into your calculator, you could. So this is the part where I'm going to show you over here on the calculator. I don't know. Let's go ahead and zoom out a little bit here. So we're just going to go ahead and hit the math button right here. We're going to scroll up, actually. You could scroll down, but scrolling up to log base is easier. Then type it in just as it appears. 1391. Now it goes to 1.7586. So 3 decimals is good. 1.759. Let's say you're at home though, and you don't have your fancy calculator, and maybe you're taking a college class and you need to figure out how to do this without a calculator because you left your calculator at school or you're somewhere else. I don't know. You can use a website. This will work on your phone or on a computer. It's called Wolfram Alpha. So I'm going to go ahead and show you that really quick. We're going to hit the little transition button here. Boom. So now we got a Wolfram Alpha website. So on this website, wolframalpha.com, you can type things in just as they appear, and it will actually solve the entire equation for you in addition to giving you that decimal answer. So we're going to type in solve, parentheses, 13 to the power of x equals 91. And then you actually do comma x. It tells it which letter you're solving for, because it can solve stuff that's not only numbers, it'll solve it with letters as well. And it gives you this weird thing, log 91, 2i, all this other stuff, but we only really care about this approximate form right here. And sure enough, we have the 1.75865. Sometimes they give you other versions of it. You could have also solved it by hand and then typed it in like this. You could have typed it in log base 13 of 91, like this. And it will actually gives you the change of base formula. That's funny. And it also gives you the decimal approximation. It gives you some other alternate versions of it. Lots of different ways to think about it. That's a cute continued fraction. Yeah, lots of different ways. Interestingly, this is a website that does what I told you. It says log base is the natural logarithm. It writes log for ln. It's kind of annoying that way that some math places do that, but anyways, that's the only part that I'm going to be going to this website for. Feel free to use it. If you decide to buy the $3 version of it on your phone, it actually shows you how to do the problems. Only do that though if you really feel like you're going to be using it a lot. So let's get rid of this. Window capture gone. Transition back. Cute. All right, number 20. Question almost similar to the last one. You need to subtract 9 on both sides first. We have 12 to the x is going to be equal to 8. And then after you subtracted 9, you do the same thing as the last problem. We got log base 12 of 8 is equivalent to the exponent. And that's it. Let's go on to that next page. Number 21. Same concepts. So we're going to do both sides. We got log of 57 equals 10x. Note how I didn't write the 10 there, because you don't write the 10 if that's the base there. And final answer, just divide both sides by 10. Almost wrote x there. I don't know if you guys could see that was going to be an x. Brain is not fully operating. I need some more coffee here. Let's keep it up. Number 22, same exact stuff. Let's just power through it. So subtract 9 on both sides first. 16 to the 5v is equal to 23. Log base 16 of 23 is equal to 5v. And therefore log base 16 of 23 divided by 5 is equivalent to v. Done, done, done. Number 23, continued on. It just looks more complicated, but don't be afraid of it. It's not that big a deal. So negative 6 multiplied by 17 to the b minus 8 equals, add 6 to both sides. I'm going to get negative 45. Now I got to divide both sides by -6. I'm going to get 17 to the b minus 8 is equal to -45 over -6. What does that reduce to? It reduces to 15 over 2 positive. There we go. Nice little reduction there. And same stuff we've been doing. Let's do it. Let's do it in one step. Let's be cute about it. Let's say we got log base 17 of 15 over 2. But instead of writing the equal sign, we know we're going to have b minus 8 on that right-hand side. And then we're going to have to add 8 to both sides to solve. Let's just go ahead and do that. If you can do stuff like that, it'll save you a lot of time and effort because you're going to be writing a lot less. And when you have to write less, you get annoyed less and you can do more math problems without getting bored. I highly recommend learning how to skip steps here and there, like just practice doing it, saying, hey, can I skip a step here? But it requires thinking in advance instead of just like doing a rote process. That's my recommendation anyways. So for instance, on this next one, I'm going to show you how I would skip a step on this problem. So if I wanted to skip a step on this problem, I know I'm going to have 8 to the n by itself on one of the sides. Now what's that going to be? So I have to do a couple things. I need to move that 1 over, and I need to divide by -7. So if I move the 1 over, I'll have -6. Then I'll divide by -7. So I'll have -6 over -7, and the negatives will cancel out. I'm telling you right now, you practice doing stuff like this, life is a lot less painful as you get older in math. Easy enough. Number 25. So again, you could try to do stuff like this, and you could actually go like full throttle into doing it in your head. So I'm going to try to explain this entire problem in your head and see if it's possible for you to process this in exactly the same way. Because if you can, then it's better for your overall math happiness, again, if you can do these in your head. So let's watch it happen. We know our final answer has to be a log base 13 of something. Every single one of these, like this final answer here, to log base 17 as our answer here, and we went to it. This one over here has a log base 8 as our answer. We know that's going to be part of it. And then what is going to be on the inside is always what's on this opposite side of the equation. So like over here we had this 15 over 2, that was it. Over here the inside was the 6 over 7. So over here the inside of it is going to be this 105 minus 8. So the inside is going to be 97. Alright, then what's going to happen after that? We know that this in the end is going to be equal to this 8x plus 10. And then, so we're going to have to, in the end, we're going to have to subtract 10 on both sides to get to it, and then divide by 8. So you could do this whole problem in one step, boom, and it's not too much effort. Now, if that is too much for you, I'm going to go ahead and show all the work one more time. So subtract 8 on both sides. If I did subtract 8 on both sides, I'd have 13 to the 8x plus 10 equals 97. I would do my log loop. Log base 13 of 97 equals 8x plus 10. I would subtract 10 on both sides. And then I would divide both sides by 8, and I would get back to this. So again, it's just if you could write less, life is easier, not a requirement. Number 26. This one's kind of an easier one. I'll show more work yet again on this guy. We got log base 9 of 24 is equivalent to negative 8k minus 7. Add 7 to both sides. And divide both sides by negative 8. Sorry for writing out in the corner out there. I didn't mean to do that, but there it is. Let's move on to the back page. Woo! We're almost done. All right, number 27. All right, so number 27, same exact stuff as we've been doing. Just got to take it step by step. We're going to go ahead and add, if I could copy correctly. We're going to add 6 to both sides of the equation to get 74 over here. We're going to divide both sides by 6 to get 18. 4 minus 10n equals 74 over 6 is going to be 37 over 3. Reducing that as much as possible. Log base 18 of both sides of the equation. You get 37 over 3 for the log loop. 4 minus 10n. You got to subtract 4 on both sides. Log base 18 of 37 over 3 minus 4 equals negative 10n. And finally, we could rewrite n is log base 18, 37 over 3 minus 4, all divided by negative 10. Oof. Okay. Number 28. This is the granddaddy problem. The reason why is quite simple. It has 2 different bases. Whenever that happens, you only have one option, and that is to take a logarithm of both sides. In class, I was explaining how we want to use ln because that will make it so we can write less. So step 1 is to do the ln of both sides of the equation. After that, we're going to use our log rules to split it up. And this is just like that example question we spent so much time doing. Now this guy is going to come down in front. And I'm telling you, if you can learn how to do some of these steps in your head, I mean, think about how much time you could save instead of writing all this stuff. Now we're going to go ahead and do A is the ln of 6. We're going to say B is the ln of 9. We'll say C is the ln of 5. And rewrite this as A plus 6 plus 8 times B equals 3x minus 2 times C. Distribute that B. I'm going to go ahead and move all the things with x to one side, all the things without x to the other. We got 6xb minus 3xc equals, we got negative 2c minus a minus 8b. Factor out an x. And divide everything by that 6b minus 3c. Done, done, done. Optional practice here at the bottom. You don't have to do these last 2 problems, but I'm going to do them anyways because I think they could show up in a college curriculum later, so I'm going to throw them on there. Optional practice, rewrite using ln and log instead of the given base. Literally just ln of 35 over ln of 2. It's going to be this guy over this guy, and then ln's in front. Or it's the same exact thing as log of 35 over log of 2. Wait. My brain failed. I said it correctly, and then I wrote it wrong. Okay. Same thing here. I could rewrite this as the ln of 1.3 over the ln of 3, which is also the same thing as the log of 1.3 over the log of 3, which is actually what Wolfram Alpha did, by the way. That's how Wolfram Alpha was answering these questions. I don't really know why Wolfram Alpha was doing that, but that is what they did. Anyways, hope you guys enjoy the rest of your Monday off and have a good one.